This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus, episode 705. This week we welcome Robert Jonkman, Vice President of Codes and Engineering at the Canadian Wood Council. We're going to talk about building science and wood, a balanced design approach. Before we get started, let's thank our sponsors. They're the reason we can continue doing the show. And don't forget after the show to continue the discussion online at afterthoughts.iaqradio.com, sponsored by First On Site. IAQ Radio Plus marquee sponsor is First On Site Property Restoration at firstonsite.com. IAQ Radio Association sponsors are ACGIH, the American Conference of Governmental Industrial Hygienists at acgih.org. AIHA, the American Industrial Hygiene Association at aiha.org. IICRC, the Institute for Inspection, Cleaning, and Restoration Certification at iicrc.org. The Restoration Industry Association, RIA, at restorationindustry.org. The Environmental Information Association, EIA, at eia-usa.org. IAQ Radio industry sponsors are Particles Plus at particlesplus.com, TSI Inc. at tsi.com, Tramex Meters at tramexmeters.com, and Healthy Indoors Magazine at healthyindoors.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick at cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
Hello, everyone. I'm sorry to report that no one identified the MGM Grand retroactive insurance litigation case as the high-profile insurance case in which a retroactive insurance policy was sold after the loss. The IQ Radio Trivia question for today, July 14, 2023, has been sponsored by TSI Inc., an industry leader in precision instrumentation for the monitoring of indoor air. Learn how to expand your IAQ investigations at tsi.com. Here's today's IAQ Radio Trivia question. Name the hard and durable wood that sinks in water due to its density, has a Class A fire rating, and was used to build the Coney Island Boardwalk. Back to you, Joe.
Thanks, Cliff. Robert Jonkman joined the Canadian Wood Council in 2005, progressing to Director Codes and Standards, Structural Engineering in 2014, and the Vice President of Codes Engineering in 2021. He has extensive experience in structural engineering, building science, and energy issues, and is active in the codes and standards development with the Canadian home builders. Welcome to the show, Robert.
Thank you. Thank you for having me.
Great to have you here. Let's start with a little bit of background about the Canadian Wood Council. Can you tell our audience a little bit about what they do?
Sure. Yeah, I'm going to just also share some slides here.
Great.
There we go. So that way some people can see what we're talking about also.
Yep. And if we could just describe it a little bit for those that are just listening
Absolutely.
to the podcast.
So the Canadian Wood Council is it's really an association of associations. It was founded in 1959, and we're actually about to celebrate our 65th anniversary next year. So it's been around for a while. July 8th is our birthday, so that just passed. And what we are is a national federation of associations, and so the members are those producers that produce lumber, plywood, OSB, glulam, and other products that use lumber.
And these are all Canadian. There's also, well, let's first, before we go there, what's the most common wood used in construction?
Well, I mean, predominantly almost all houses are built with wood. So lumber is the most predominant, and hopefully they're using a wood sheathing product like OSB or plywood on the outside of the building so that the house can withstand the wind loads and the earthquake loads.
And is it Douglas fir? I mean, I was always confused by it. It's like three different.
Oh, I see. Spruce pine fir is spruce pine and fir is a mixture that is used in Canada quite a lot and actually exported into the United States as well from Canada. And that is our most common, by far, our most common lumber that's used.
Now, when you say spruce, pine, or fir, is that three different types of wood, or is that three different names for the same basic type of wood?
They're all softwoods, and they are with the very similar properties, but they are three different types of wood. And because they have similar properties, we mix them together as one grade. In Canada, we actually only have 4 species groups of lumber. It makes it a lot easier to design with it when you know that there's only 4 material properties to deal with.
I see. And I'm just curious right now, you know, we're in the Northeast of the U.S. here, and we've been getting a lot of smoke from the fires. Is that going to affect the availability of wood for the construction industry?
It's having a big impact. I was going to get into that a little later, but it's probably the biggest wildfire season that we have had, and it's taken. Currently now it's only July, and from what I understand from our colleagues at the Forest Products Association, so far the fire has taken about 12 times more wood than we actually harvest on an annual basis.
Wow.
So it's in the I have a stat somewhere along here, but it's about well, maybe I won't remember we'll talk about the stat later.
A little more. Later in the show, but you mentioned your colleagues, and I think there's a group called the American Wood Council as well. How are they different? Do you work together if you do?
Yeah, we have the American Wood Council, and we have a number of other groups that also we work with. The APA, Engineered Wood People. We have Woodworks, we have Think Wood, and we have SLB. So American Wood Council is very closely aligned with the Canadian Wood Council. We both deal in codes and standards work. And actually, Canadian Wood Council is a member of the American Wood Council. And actually on Sunday, I'm going over there for their annual set of technical committee meetings for the whole week.
Where are they located?
They're in Washington, D.C. area.
On the D.C. Okay, interesting. Now, well, we called this show Building Science and Wood, a balanced design approach. Can you talk a little bit about what is meant? Well, what should our overall philosophy be in designing? Let's start with that and then get into a little more about the balanced design approach.
Sure, yeah. There's a whole pile of competing aspects to designing a building. And sometimes I say competing because sometimes, for example, with resilient design, you may want to use more materials. You likely want to use a wood sheathing to resist the wind and seismic loads for your building. But some builders in certain locations say, hey, I have another panel product. It's called insulation, and I want to use that instead of the wood sheathing. So that kind of competes with it, with that. Now, of course, you can use both. You can use the wood sheathing and on top of that, put some insulation. That's the best approach. But there's also the affordability side of things. And so which one do you pick? Again, you want to pick both of them, but it does play into the decisions builders make. So we have resilience, we have the energy efficiency aspect, we have the affordability aspect. Now, when we go back to energy efficiency, the more insulation, the better, right? You want to have a highly efficient building envelope. And but that impacts the carbon footprint. And so there's a huge scrutiny worldwide now, for sure in Canada, about having a decarbonized environment, so low carbon materials. And so, you don't want to pick too many materials. And B, when you do pick materials, you want to have materials that have, the best carbon footprint available. And then, of course, there's the fire resistance and durability aspects as well. So all those things have to be considered by the designer to make sure that they have that, what I call the balanced approach.
So combining these resilient design, energy efficient design, carbon, affordable design, fire resistance, and durability. I know we have a big audience in the restoration world, and they deal a lot with things like fire resistance and durability. Do you see more emphasis in those areas today than we have in the past?
Yeah, all of these are being emphasized more. We've had windstorms that come through. That's everybody focuses on. Hey, let's make sure our buildings are wind resilient, even climate resilient. When we have those heat waves that go through, the news yesterday was talking about all the heat waves, not only in the U.S. and Canada, but also Europe. So climate resilient as well. Energy efficiency, of course, has been important for probably about 5 or 6 years, or at least focused on for 5 or 6 years, but that does lead into the carbon aspects. And then, of course, we have so many people moving to North America and we have a huge shortage of houses for them to go into. So affordability is also being scrutinized as well. And then wildfires. So we want to make sure the buildings are designed so that they are at least wildfire resistant. And then we don't want the materials to rot. And so there's an increase, especially in Canada, there's some standards that are being developed to make sure that all the products used are going to be durable for its use.
I've got in my notes from talking with you earlier in the week that a wood frame house can resist an EF2 tornado. Is this any wood frame house, or does it have to be built in a specific way?
Well, that's a good question. There's even a Globe and Mail article, which is a Toronto, Canada newspaper, that talked about the fact that, hey, are the houses keeping up with the extreme weather? And I gave an interview for that. And in general, wood frame homes perform very well experimentally, both in the US and Canada, in even the worst of earthquakes, with just a few, paying attention to some detail. They act very well, but no, not all homes can. And this is actually very front of mind today for me, because just yesterday there was probably an EF0 or EF1, very low tornado, but it still wrecked 125 homes only a few miles from my house. It was a close call. So that's first and foremost in my mind, is that component about resilience. And so we do have some strategies, and they are in this S520 standard. It's a brand new standard in Canada that deals with how to make sure your home is highly resistant. And I am going to go to this slide here that describes what I talk about in about an hour presentation. And I'm going to boil it down to like 2 minutes here, but how to design a highly wind resistant home. And this is based on the concepts of that CSA S520 standard that's just brand new. It was published in 2021 or 2022, I forget now. First step, making sure that the roof sheathing is attached well, and the standard goes and it describes a better way of ensuring that the roof sheathing is fastened well. If the roof sheathing lifts off, your house is going to be toast from either water or the extra wind load that hits it. And then gable end roofs, those triangular portions of wall that goes up to the roof line on certain homes. And those are very susceptible for a few reasons. One, they're not constructed as well. And two, they're higher up, so they have higher wind loads. And then just making sure everything in the upper framing is connected to the lower roof framing better. Those things include chimneys, if people still have chimneys attached to their home, or even dormers. Seen a number of houses where the dormer has flown off. ensuring just like the roof sheathing is attached well, making sure the wall sheathing is attached very well and with nails that are perhaps even better than commonly used. There is something called the roof sheathing ring shank nail. It's kind of like a combination of a screw and a nail, and you can drive them in with power nails, but those allow the sheathing to be fastened a bit more securely. Then also making sure there's enough wall sheathing so that the building doesn't rack sideways. Again, I mentioned the use of insulation, sometimes in place of wood sheathing. And so while we endorse making sure that there's enough there's wood sheathing used on the house, it should be used in enough locations. And so I've shown a building, it's very small here. The center image is a building that racked during construction about a year ago when a derecho came through the Ottawa area and just shifted that house while it was under construction.
Yeah, I'm wondering, with respect to the wall sheathing, what's the difference between using OSB and plywood in that respect?
OSB and plywood act very similarly. They have the same properties, and in the standards, they're treated virtually the same way. So no strength difference. It boils down really to the thickness and the nail patterns that are used to fasten the sheathing to the walls.
Yeah. Okay.
So
ahead.
Continuing on here with what's probably the most important is the overall uplift of the building. And so keeping the roof on, we talked about the roof sheathing, but making sure that the roof framing is attached well enough to the walls below. The codes allow it to just be nailed, but hurricane straps, hurricane ties, that's what's really needed. And not just hurricane ties or straps that are going from the roof trusses to the double top plates that are typically used in houses and small buildings, but then getting from the double top plates into the studs and across all the different assemblies. And so ensuring that we have a complete load path tied together with strong materials, whether that's overlapped wood sheathing or separate metal straps that do that, bringing it all the way down to the foundation is key. And then the last 3 points are very, they're not as much the structural as much as keeping it dry, but underneath the shingles, having a very robust underlayment that sticks to the roof sheathing is really good. I've seen a lot of roof shingles blow off, but if they have something underneath it that protects the inside of the house from water damage, you're far better off. And then the other ones is a bit more expensive, but making sure you have high strength garage doors and also high wind resistant windows.
Rob, I'm wondering, I feel like I'm looking at a Florida code requirements in Florida. Is that accurate to say this is pretty similar to what you would be required to do in certain areas of the country or in the United States anyway? I don't know about up in Canada, but it seems like these same practices used there are probably becoming more important wherever you build.
I would say so. It's similar. It was inspired a little bit by the Florida building code. We worked with somebody who is a designer engineer in the Florida area and who had contributed to the Florida residential code, but they're based on a slightly lower load than you would get in that area. And one of the although all the concepts are identical, tying it down, making sure your roof sheathing is fastened better, all these concepts were based on EF2 level hurricane or EF2 level tornado wind speeds, which are about 200 kilometers an hour. If you have your calculator, you can convert that probably to miles per hour, but it's high wind, but probably not quite as high as the Florida coast would see. And so one of the differences is probably the windows. And I know I'm not an expert on windows, but I know from another window expert that the quality of glass you can get varies. They could be all hurricane resistant, but you can have a hurricane resistant that's suitable for Florida. You can have a hurricane resistant that's suitable for New York. And so the New York hurricane resistance is sufficient for EF2 tornadoes based on what my expert told me.
Now, another topic we hear a lot about is carbon and climate change. I wonder if you could touch on that and how wood construction stacks up essentially with respect to carbon.
Sure. I like to quote a colleague of mine first by saying, if someone was to invent a self-replicating solar-powered carbon dioxide sucking machine that stores carbon and energy in a building material while producing oxygen as a waste product, they'd be rich. It's my colleague from the Canadian Wood Council who says that. And of course, he's referring to trees, and they absorb carbon. They do this at their big plants, their factories of storing carbon. They do this through what we learned in high school, photosynthesis, where the carbon dioxide goes in, combines with water and sun, produces what ultimately turns out to be the wood, the sugar that converts to wood, and beneficial to everybody is the oxygen. So the carbon dioxide is then changed into oxygen. And what I like about that is the wood then stores the carbon from the carbon dioxide and releases the oxygen. And that's what the world is looking at as a culprit for climate change right now. So wood is 50% carbon. That's a fact that you can look up many places, including the Forest Products Handbook. The rest is oxygen, hydrogen, a few other things that are less important. And I can go into details using the periodic table, if you'd like, about how the math works out. But chemistry wasn't my forte. That's why I went into structural engineering. But there's something called the molecular weight, and that's the comparison between carbon and oxygen. And so when you have carbon, it has a molecular weight of about 12, and you have oxygen 16, and there's 2 oxygen molecules in carbon dioxide. And so when you ratio the carbon dioxide over carbon, you get a ratio of about 3.67. And so that all boils down to, if wood is 50% carbon, and you do all that math that I just showed you with the periodic table, each piece of wood, each kilogram of wood, dry wood, has sequestered over its life 1.83 kilograms of carbon dioxide. You can think of that like, hey, we weigh like roughly 200 pounds, and we eat a lot more than 200 pounds of food. But as we grow and in our age, we eat way more weight in food than our body is. So the tree is doing the same with carbon dioxide. It's taking in this carbon dioxide, sequestering that, and building up its muscle, call it, in dry wood. And so that's what is very beneficial to the environment. And I like to put that into terms we can perhaps relate to. If you had one telephone pole or a utility pole that's made of Douglas fir, that's another wood species that's prevalent in both Canada and the western part of the US. And it's commonly used in our telephone poles or utility poles. And they're about 1 meter cubed of volume. And when we consider the weight, the density of that Douglas fir, and we talk about that 50% of wood is carbon thing, and we do that math with the periodic table, it turns out that each of those telephone poles sequesters about 1,000 kilograms, 900 kilograms of carbon dioxide. So that's a very good news message for fighting climate change.
Now, why, I guess another thing is, why do we care so much about this carbon issue?
We care a lot about it because now, as we build more efficiently, in the last 10 or 15 years, we've had this focus of building energy efficient homes. And that's great. We're getting to some more energy efficient homes. But as we build those more energy efficient homes, the proportional impact on the environment due to the materials increases relative to that operational energy that is used to keep the house warm or cool in the summer. And so that's why it's being increasingly scrutinized about what materials impact of those materials have in the environment. It's not just the operational, the result of the operational energy in the form of operational carbon, but it's also what we call the embodied carbon, the carbon that goes into the atmosphere as a result of making the materials. And so that's why we need to focus on carbon. And really, we got to focus on decarbonizing.
Now, I got a text, but I want to reword it a little bit. Is the CO2, when a tree dies for whatever reason, you've got these fires, you've got trees that fall because of windstorms and so on and so forth.
Sure.
Are they still sequestering that CO2, but less? Is it being released more rapidly when they die?
It starts to break down and release. Yes.
Okay.
Yeah, that's what happens. And of course, we've talked about the wildfires. That's releasing it very quickly, which is bad. And so that's where our friends in the forestry side are working with government to try to make sure that the way we harvest forests are done, considering all aspects. Again, it's a balanced approach. We don't want to wipe out all the forests, but at the same time, we want to make sure we have some fire breaks, and we want to harvest it in a way that doesn't leave a lot of wood on the ground. And they're very good at doing that, but focusing on making that even better is something that can help, because we leave things on the ground and they will start to rot. Of course, it nourishes. That's nourishment for the ground, and then that's good. It's nourishing for further trees. But the more we actually sequester into products, the better.
I'm curious, what's the take for the typical tree nowadays to grow to the point where you can use it as lumber? How many years?
That's a good question. My understanding, relying on my friends at the Forest Products Association, and some of our mills too, it's somewhere between 40 to 80 years.
Oh, really? Wow.
So it's growing, it's sequestering carbon dioxide for the 40 years. But the thing we have to keep in mind is it reaches a maximum and then it starts to absorb less carbon. And again, I'm talking a little bit out of my structural engineering world here, but it's very beneficial to actually harvest those trees at the peak time when they're done, at the peak of their carbon dioxide sequestering phase, before they start to go downhill as far as the absorbing of the carbon, and also definitely before they start to die off and, as you mentioned before, drop in the forest and start releasing that carbon dioxide.
40 to 80 years. That's fascinating to me. I thought it was a little quicker than that. But maybe that's because I'm thinking about wood being grown down in like Georgia, et cetera.
That could be, yeah.
I think it may be a little quicker. They've been able to get that 20 years for the pulp mill. Somebody's telling me here on the text. So that's very interesting. Okay. I tell you what I think is this is a good break point. I want to stop for halftime. And when we come back, I want to go into a little bit about things like cross-laminated timber, mass timber construction, which I know you're prepared to talk to us about. So let's take a break. Yep. We'll be back with the second half with Robert Jonkman. I'll get it right, Rob, in just a minute. Our marquee sponsor is First On Site, your trusted full-service disaster recovery and property restoration company at firstonsite.com. Association sponsors are ACGIH, Advancing Careers of Professionals in Environmental Health, Industrial Hygiene, and Safety, interested in defining their science. ACGIH.org. AIHA, Healthy Workplaces, A Healthier World. AIHA.org. The Environmental Information Association, EIA's multidisciplinary membership, collects, generates, and disseminates information concerning environmental and occupational health hazards in the built environment at eia-usa.org. The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry, IICRC.org. The Restoration Industry Association, the oldest and largest nonprofit professional trade association dedicated to providing leadership and promoting best practices through advocacy, standards, and professional qualifications for the restoration industry at restorationindustry.org. Industry sponsors are Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us, particlesplus.com. TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations, tsi.com. Tramex Meters, developing modern dynamic moisture meters and humidity monitoring systems since 1974. TramexMeters.com. And Healthy Indoors Magazine, a free online magazine for industry professionals and consumers, healthyindoors.com. All right, we're back with the second half of our interview with Rob Jonkman here with the Canadian Wood Council. Cliff, I think you've got a follow-up question for Rob.
Yeah, I do actually. I had an audience member text me earlier today, and the question really dealt with wood following fire damage restoration. So the wood in many situations is cleaned. Oftentimes it's abraded with perhaps dry ice or in certain situations sand or glass beads and so on and so forth. And this really prepares it for a coating. And in many situations, what happens is this wood up in attic spaces or areas that were affected by fire, after the cleaning is going to be coated, and oftentimes a latex coating can go on it. Sometimes a shellac coating can go on it. And really the question is permeability really an issue, or really, would it be a concern?
So is permeability a concern for a finish? Is that what you're asking?
No, for
coating.
wood. Yeah, does the wood need, I guess, does the lack of permeability, some of these coatings are permeable, some of them are not. So yeah. Would the lack of a permeable coating really cause problems on wood?
It could, I think. If you put a treatment on wood where wood is on the outside of your wall, you're talking indoor use of wood?
Oh yeah, this is all indoor.
Indoor. That's a good question. I have not dealt with that type of a question before. I think more from a building science perspective, when you have coatings on the outside of wood that restrict its permeability, and wood is fairly permeable. It could act as a vapor retarder, because it's actually a smart vapor retarder itself. So it changes its permeance based on the moisture content in the wood. And so it can act as a smart vapor retarder, having a very low permeance when it's on the inside of a house, and where the relative humidity is low, and a much higher permeance when it's on the outside or it's in a high relative humidity area. But as far as issues with indoor wood having a low permeance, I don't really have a comment on that.
Well, the one thing I can tell you historically, I've seen that has not been a problem. If it was a problem, I think that the industry would know about it. And in certain situations, it's impossible to seal all the sides of the wood.
Right.
In certain situations, I can't get to all of it. So, it's the edges, or it's one side, that's up against the framing. And really, personally, I haven't encountered it. And I've been doing this over half a century. But, we do get questions on it, and there's a debate because I think certain other materials, I think permeability is a bigger issue. And plus, it's not solid wood. You have a piece of wood, you have 14 inches of airspace, and then you have another piece of wood. In many situations, it's not solid construction such as a log cabin or whatever. But
Yep.
I just wanted your opinion.
I do have a perspective from a timber frame
Right.
perspective. I used to work at a timber frame manufacturer for about 9 or 10 years as the supervisor of the design and engineering department. And so I engineered a number of timber frame buildings. And of course, the house is very dry. It could be very dry in the middle. And when you have larger timbers, it could check and make a gunshot sound as it shrinks. So wood certainly does allow moisture in and out, and it shrinks and expands accordingly. There's well-known equations of how to deal with that. The other thing about wood and its ability to take moisture in and out is it's actually good for the indoor air quality, to have the humidity of the building, to have the wood kind of be a buffer for excess moisture at one point and then releasing it back when it's drier.
Thank you.
Few things my log home here is good at. It's not very good at insulation, that's for sure. But
I think
anyway,
the techniques have improved with log frame homes too, to make them more energy efficient and airtight as well.
yes, absolutely. I've got an older one here, but we get by. I've got a tight lid on top, and it seems to help quite a bit as long as I have things sealed at the bottom and at the top. I've had pretty good luck with it. But
how old is your log home?
It's about 50 years old now.
Okay.
So it's older. It looks like it's, well, anyway, let's talk a little bit about what is cross-laminated timber. That's something we hear about more and more now, and I'm not sure if our audience is that familiar with what it is.
Sure, yeah. You can visualize cross-laminated timber as taking a number of 2x4s, they're roughly 2x4, call them 2x4s, and laying them down, side by side, flat edge to edge. So what I mean by that is line them down on the ground so the wide part of the stud is exposed, like you would a fence lining up fencing beside each other. And then you put another layer that's perpendicular to it, and then another layer perpendicular to that again. So you could have 3 layers of tightly spaced 2x4 materials, or 5 layers, or 7 layers, or even 9 layers to form longer span floor systems. And that's what cross-laminated timber is. And it's pretty neat because it stores a lot of that carbon that I mentioned earlier. It can expand, or it could span, I should say, a long distance. It can replace things like tilt-up concrete in some cases. It can make pretty durable walls and strong walls. And that's what it is.
And why is it becoming, it seems like I'm hearing more about it. I'm not sure exactly why. Why is it becoming more popular?
I think it's back to, it is becoming more popular. There's a number of manufacturers in both Canada and the US now that are fabricating cross-laminated timbers, CLT we call it for short. But it did start in Europe about 15 years ago, and in Canada about, I don't know, I'd say time flies, so I'll say 5 years, but it's probably more than 5 years. And it's popular because of that carbon story that we've been talking about before. It's one way that building owners and designers can say, hey, I am reducing my carbon footprint. It also can be used in buildings where there's very little waste, and it could be used in buildings where there's only 3 or 4 contractors putting up all the floors and the walls with a crane. And I've seen some of the earlier ones where there's just like a wheelbarrow of sawdust at the end of the 9-story project, and that's your waste.
And what about mass timber construction? That's another thing we hear more about. We did a show with, I think it was Benson Wood was the name of the company. And the name of the owners is escaping me at the moment, but they were talking a little about mass timber construction. Yeah,
that's probably Ted Benson.
That's right. Ted Benson. Yes.
Yeah. He's a timber guru. He's written several books on timber framing. So mass timber is kind of the generic phrase we give. So CLT is a form of mass timber. These products I'm showing on the screen now, laminated strand lumber, laminated veneer lumber, parallel strand lumber. Those are all engineered materials that also are part of the mass timber family. But those are older ones, and I bet you a lot of your listeners have heard of those before. They're very popular. Rim boards, for example, LSL all the time. CLT is a little newer, but there's also even newer stuff coming around. Well, it's new and it's old. Nail laminated timber. Nail laminated timber has been around actually in some really old 100-year-old type of buildings. But now it's part of some standards. There's actually standards that have been developed. In Canada, at least, there's a new standard out called CSA 0325, brand new standard talking about how to make sure that the quality and the performance of this is done correctly. And that's just taking a bunch of 2x4s or 2x6s, or not sure how deep they would go, and then nailing them from the large side into the next piece. So it's forming, so the strong side is, the strong dimension is vertical. So it's like a bunch of closely spaced floor joists. They're all tight together though and nailed together, and they form very strong floors. They could even be stronger than cross-laminated timber because they're all in their strong direction. So that's another part of the mass timber family. And even newer, especially environmentally friendly, is something called dowel laminated timber. And so that takes the same type of concept, laying a bunch of 2x4s or 2x6s or 2x8s on its edge, and instead of using steel nails, using wood dowels and drilling them in. And that is really cool because the end of life story for these materials is really good because you can always reuse these. There's no danger of cutting nails with your saw. Even on site, you can cut a hole in it if you need to without damaging your saws. So that's another mass timber product. And then the last one that I'm not too familiar with, but I know is around, is mass plywood panels. So if you visualize going to Home Depot and looking at the stack of plywood panels on a orange, racking system, but instead of them all being loose, they're all glued together with adhesives, and those are used to span, quite far as well. And what I'm now showing on my screen is a big loader, a bulldozer type thing, and it's sitting on top of a 40-foot panel. It's 10 inches thick, 4 feet wide, and actually it's supported on two supports that are 28 feet apart. So it's cantilevered a little bit on each side. And this big, heavy chunk of machinery is causing this mass plywood panel to deflect 5 inches, which is pretty cool.
Now, one of the things that I think our restoration people would ask you, though, is about the durability of these products when exposed to water. We get that a lot. Are they more problematic when exposed to water as opposed to a 20-foot 2x20, the 2x12 or something like that?
So the mass timber in general, or?
Well, I guess it would be different for each type, huh?
Yeah, it would be, but really you got to just first of all, they just need to be able to dry. They're not going to rot in a few days.
Okay.
And you do need to you want to dry them as quickly as you can. They're not as susceptible to mold as, for example, papery products are, but yeah, design is important. Having correct design, construction details, very important.
All right. How does, we see wood construction a lot in North America, over in Europe and other parts of the world. You get more concrete, cinder block, even down south in Florida. How does wood stack up as a product for construction why wood? There you go.
Well, we talked about the carbon sequestering aspects of it. It's also a very good natural insulator. And I can talk more about that later as well, but it insulates much closer to actual insulation than concrete and steel do. And so if you're using that in for example, a wall system, you can get a much higher performing wall from an insulation perspective than you would, for example, a steel stud wall. And it also has a very good strength to weight ratio, and it's very lightweight. So I've seen some cases where they could use wood framing on a site where they couldn't have used a heavy material because of either the soil or what was below grade tunnels or other infrastructure. And wood is also healthy to have in the home. And then, of course, as we're getting to these heavier type of mass timber products, there are bigger, taller opportunities for wood to be used as well.
How tall is the building? Let's put it this way. The tallest buildings using wood construction, how high can we go now?
There's probably not a specific limit, but I know in Canada, and forget if I mentioned this already to you, but there's a building called Brock Commons in British Columbia, the west coast of Canada, and it's 18 stories out of mass timber. 17 stories of mass timber plus one concrete, so 18 stories in total. It can go tall, but there's other ones that are being built around the world, not just in Canada or the US, but around the world that are either planned to be much taller or are in the works and they're slightly taller.
Interesting. And could you go into a little more and elaborate on the insulation value of wood?
Sure. Yep. Flicking through my different slides here. The reason wood has high insulative properties are those air pockets that are within it. And so that allows the wood to become very insulative. Let me show you or describe here. I mentioned steel and concrete earlier. Wood has an R value of about 1.2 per inch. That's the R value in US terminology. 1.2 per inch. Insulation, 4, 5, maybe 6 R value per inch. Concrete is 0.06, and steel, of course, is a conductor, so it doesn't even count. So wood is 20 times more insulative and 40 times more insulative than concrete and steel, and it's all dealing with those. It's all because of the air pockets, and that's what makes wood naturally an insulator.
Interesting. Okay. Let me get to, let's see. Is it, again, going back to the fire perspective on things, I think a lot of people, when they see these large wood buildings, they're concerned about fire. And I wonder if you could touch on that topic for a moment.
Sure. Yeah. I'll talk about fire too, but what I wanted to highlight was we used to build older buildings, taller buildings, I should say. There's some old buildings that used to be taller, and then restrictions came into the code, lowering the permitted heights of buildings. And so you asked about how tall can we go. I'm showing that Canada in 2017 built this tall wood house, which we refer to as Brock Commons, about 57 meters. There's another one built in 2019, 85 meters, and another one planned somewhere in the world that's 300 meters. I don't know where that would be, but you can see they're growing, and that's because the code recognizes that wood can safely be used. But examples of old buildings that were wood frame or wood buildings before, there's one in Australia that is pretty famous. It's called the Royal Albert Hotel, and it was built in the early 1900s and had 8 stories. Now the outside of the building is stone or brick, other materials, but the inside, the structure supporting it is heavy timber frame. So that's an example from Australia. And in Canada, we have one that's 9 stories, also built early 1900s, 7 stories above, 2 below, and there's a nice little pub inside this one, which I've been into when I've been to Vancouver. you can see the inside of that is, there's a nice timber frame in there.
Yeah, it's beautiful.
And then Brock Commons, this is an example of the Brock Commons I was talking about. The beauty of it also was that a lot of components were prefabricated and just craned into place, so it went up very quickly.
Rob, go back to that if you would for just a moment. What's that blue? I mean, where he's standing there, is that just on the exterior of that wood?
Yeah, that's just on the exterior of the wood. I think that was part of the clip that was there to house the panels.
I didn't know. I thought maybe it was insulation on top of there, but it wouldn't make any sense. Okay.
Yeah, no.
All right. And then you were going to go over to the fire.
Fire, yeah. Fire, the thing about mass timber, it does perform predictably. I have a structural engineering background, but our team has a number of fire experts as well. And they tell me that the heat from the flames drives the moisture inside of the timber. And so it makes the center less susceptible to fire. And also the surface, as you probably can witness when you go to a campfire, the surface chars. And so you don't start a campfire with a large log. You start it with some small kindling to get it really hot first. And so it chars, and that actually forms a protective layer. So that was our theory. It is reality, but we did test that. We tested it in Canada last summer through what's called a mass timber fire demonstration test program. And it was actually the largest mass timber fire test in the world. I think it still is. And when I give you some of these slides, I'll give you the link as well, but there's a whole microsite link that you can see that goes over the results of this. But in general, I'll go over it quickly. It was a 2-story, 4-bay structure. If you have your calculator handy, it's 334 meters squared building. So whatever that is in square feet, probably around 3,000 square feet.
Okay.
And so it was all mass timber. And what I thought was really cool, for those that are viewing this, that's the size of the mass timber that was in there for a floor system.
Wow.
It's showing about 12-inch deep. This looks like a nail laminated timber being hoisted into place. And I'm showing now an image of this 2-story building. It got really hot. I was there. I witnessed this test. So hot that those pylons that you see there melted. The back of the TV screen that was about the distance we are now, like from this image, the back of that started to melt, and all the audience had to go back a little bit further. So it became a very hot fire. But in 25 minutes, it extinguished itself. It developed this charring effect and went out by itself, despite the fact that there was a bit of a breeze, which helps propagate the smoke, the fire. And it went out all by itself. There was, of course, a fire crew handy in case it didn't, or in case there was another problem, but they weren't needed, and it just died out. So it's not just all fantasy. It does actually go out.
That leads me to another question here. Now, you showed that charring on what looked like, I don't know, a 4x4 or a 6x6, whatever it may be.
Yeah.
Does the same thing happen in a forest fire?
That's a good question. I bet you there's a lot of logs that are falling down, that only the outside is damaged.
Yeah, it seems like you might be able to still use some of that, but I don't know. I always assumed it burned all the way through, but now I'm starting to think, well, maybe it doesn't. Maybe there's still some use for that.
It's possible. It might not be cost effective to do, but it's possible.
Interesting.
I'm not a wildfire expert. I know that we want to prevent the fires, and I know how to do that with a house. But from a wildfire perspective, it's a very good question.
Hey, Joe, one
Yes,
of the things that happens with wildfires is that, if you're having pine, or if you're having spruce, or if you're having fir in those soft wood trees, you have a lot of oil. that's actually, in the, they don't have leaves, they have cones. And that oil, kind of contributes to it as well. I mean, it's going to, it's a built-in oil source, actually. So.
And those wildfires,
question.
possibly because of what you just brought up, Cliff, is they're super hot and they can jump like a kilometer even,
Right.
From what I understand. They can jump. There's the heat from it is so hot it can jump a long distance across a body of water and keep it going, propagating in the adjacent forests.
I've got a text question. I don't know if this is something you can answer or not, but I figured I'd throw it out there again because of our restoration audience. And the question is, and we're talking about the mass timber construction, wouldn't the permeability be very low and make it difficult to dry? So these guys are always thinking about something that got wet. Is it going to be more difficult to dry out mass timber construction than it would be regular construction?
It's possible, but also it's not as susceptible to the damage of the moisture. If you're talking about things like oriented strand OSB, for example, that's probably going to be ruined by moisture, whereas this is probably salvageable. I'm sorry, I just don't have the expertise in the restoration side of things.
Hey Joe, if I could comment,
Okay. Cliff?
I think it depends where it's at. Like if these are floors that are in a building and the water's from up above, what's going to happen is the majority of the water is going to run off. It's different if you have flooding. So if you have catastrophic flooding, and the water covers that entire floor and remains on top of that entire floor for some period of time, it's going to be a whole lot worse. And I think there it would be a different story.
Could be, yep.
Rob, I know this is not your area of expertise, but I want to throw it out. We had talked about this earlier, and I had a text from our audience. What about the cost of this type of like mass timber construction versus typical construction? Is it a huge difference, or?
That's a good question. Also, I know there's some case studies that we've done even 5 years ago, and it shows that it can be comparable. The one problem recently, though, was high lumber prices brought the lumber and CLT, consequently mass timber, up. But as we get more contractors and builders and developers more comfortable and more knowledgeable about building with wood, it is comparable, or it's going to be cheaper.
Interesting.
And when you consider the carbon price, eventually, like they're doing in Europe, there's a price to carbon.
Okay.
And when you factor that in, I think it'll be a definite win to be building with wood.
Very interesting. Do you have an extra 5 minutes, Rob? We normally finish at noon, or at 1 o'clock. But if I think we can
sure, yeah.
I've got another important topic or two here. I'm going to have to skip the roundup because if we go to roundup, we're going to not be able to give you controls back according to my engineer here. So we'll skip what we call our roundup here. But I wanted to get into environmental product declarations because I think that's an important topic, and we had prepared to talk about it and we didn't get a chance yet. Let's get to that.
Okay. I always visualize environmental product declarations like that chocolate bar. I have another one right here. And the back of that chocolate bar has a list of ingredients in it, the nutrition and the nutrition facts. And an environmental product declaration is very similar to the nutrition facts of food. And so, for a given size or a given unit, a given size of that chocolate bar or that food, there's the nutritional aspects of it, or there's the life cycle impact measures for that wood product. And so one of the main ones we talk about now is the global warming potential, and we equate that to the carbon dioxide equivalent in kilograms or whatever units. And so an EPD then gives you an environmental product declaration, then gives you an idea of the impact that this product will have in your building. And people are tempted to compare materials with based on their EPDs. It's not strictly permitted or good, but unless they have the same kind of use. So if it's you got to compare it in the right way to be able to do that, and then you can, is my understanding. But it certainly gives you an impact and for that material, and so that's what it's all about. And we do recognize the importance of EPDs. They're becoming more and more important. The wood industry has been putting out EPDs for many years and decades even. And so we tag team with who we talked about earlier, the American Wood Council, to put out industry environmental product declarations for a number of wood products. And they give you all that information I was just referring to. And of course, as I mentioned, the main one is the global warming potential. But more and more people are saying, okay, well, we want all materials to have these environmental product declarations. So I think this will become more important, and it'll also have to become more regionalized as well.
And the last thing I wanted to make sure we got in here is, what do you think? Net zero is a big thing, especially here in the States right now. The DOE net zero building program. We're trying to build in a way that's net zero. What do you think is a good wall for net zero?
I think a good wall, it depends on all the rest of your building, but I think a good wall is probably at most an R value of 30. And it'd be wood framed with it'd have to be with exterior insulation. But remember, going back to the very early part of this podcast, we want to use a balanced approach for that wall. So a good wall is going to have a decent or a good enough amount of insulation, R30 probably at the most. It's also going to have the ability to resist the wind loads and the earthquake loads. So it's going to have some form of sheathing on the outside, wood sheathing or structural sheathing, OSB or plywood. But it's also going to consider the environmental impact. So the insulation that you put on the outboard side of it is going to be something that has the best EPD that you can get. The environmental product declaration will show which one you should use. And it might be something like a rock wool, or even perhaps better, a wood fiber insulation. I know there's a new plant going into the eastern area of the US, I think it's Maine, that's producing a new wood fiber insulation. So the wood fiber insulation that's produced can be either kind of a softer stuff that you can put into the cavity of your wall, and you can also produce more rigid ones that can go outboard of your wood sheathing.
Now, when you say R30 is kind of the upper end, why is that? Is that because we get diminishing returns beyond R30?
Yep, I think so. And people are doing analysis of what can get them to a net zero house. And so when you have a net zero house or net zero building, based on the experience, at least that we have in Canada, we have a number of builders that are building net zero energy homes, and they top out at about the R30, effective R30 insulation to get that. Combined with all the other stuff, the roof insulation, perhaps solar panels, all that stuff. But the wall system itself can be about an R30.
And Cliff, did you have any final questions or thoughts?
Just one. Any comment on adding fireproofing to wood, or adding other types of additives, anti-termite or wood destroying insects, or treating like telephone poles and so on and so forth? Does that adversely affect lifespan of wood, any of these treatments?
Well, you bring up the telephone poles or utility poles. that's crucial to have a treatment on it, but it makes it basically permanent. We have permanent wood foundations as well that are used, particularly in the north. They're treated with chemicals that can allow them to last indefinitely. Also, it's used in the north a lot because it's very hard to get concrete foundations or concrete trucks in remote areas. So bringing in PWF's permanent wood foundations there is crucial. But yeah, they need to be treated for those applications. Also, they need good detailing as well to make sure that the water drains off.
Thank you.
Fire treating you brought up.
Right.
I'm not sure about the extra benefit you get on that, because as I mentioned, wood does char. And so from a mass timber perspective, I'm not too aware of treatments that can be used or that are needed for that.
Rob, before we go, we always like to give our guest the last word. Is there anything we missed that you'd like to add? I think we actually got through what we thought might take 2 shows. So congrats on that.
Thank you. What we didn't get through is like the biophilic aspects of wood. We also didn't talk too much about the indoor air quality of wood, even though that's your show. But in both regards, wood is pretty favorable in those two. So we could talk about that at some point down the road. Hospitals are using wood to make people feel better. And actually, it's been documented to show that if you bring nature like wood into a building like a hospital, they heal quicker. They're on the fast track a little bit better when you have an environment such as that.
Very interesting. Very interesting. I think sometimes people look at these shows and we're going to talk about wood, and they don't realize how wide a range of topics we're going to be talking about. It just looks like wood, but we've gotten into quite a few things. I was very, very interested, and I'm glad we were able to get you on. I look forward to seeing you at summer camp.
Yeah, very good. Yes. Thank you for the opportunity here.
Our pleasure. This is Radio Joe Hughes saying thanks to this week's guest, Robert Jonkman from the Canadian Wood Council. My co-host, the Z-Man, Cliff Zlotnick. John, you got to have faith at the controls. Most importantly, our loyal audience and our sponsors. We'll be back next Friday at noon with the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.